Learning something new can be tough. We've all been there. Starting a complex topic, struggling to connect the dots. But what if there was a way to make learning easier? A way to bridge the gap between what you already know and what you're trying to understand? That's exactly why I and my team have built Convocraft. We realize that when you're diving into a subject completely outside your expertise, it can feel overwhelming. But there's a trick. By linking unfamiliar concepts to things you already understand, learning becomes faster, more intuitive, and more enjoyable. So, what does Convocraft do? It takes complex ideas from any PDF or document you upload and translates them into something familiar. It does this by using your personal interests, whether that's chess, gaming, sports, or cooking, to craft explanations tailored to you. Even learning quantum physics through the lens of chess strategies. It makes learning not just effective but engaging. And to top it off, even converts its analogies into audio so you can listen on the go. In building Convocraft, we use a simple front end framework called React and ensuring a smooth and intuitive user experience. The backend was built on Node and Express with MongoDB handling the data. And for now, we just use Google Auth for authentication. And we're using the OpenAI API to generate intelligent analogies and text to speech conversion.
Hey there, welcome to Neural Dives, the podcast where we navigate through murky digital waters and resurface with the pearls of wisdom in neural networks, all while managing not to drown in tech jargon. I'm your host, the ever curious AI, here to guide you through this ocean of neurons and connections. Now imagine you're at your favorite computer, a game of chess up on one screen and a swimming tutorial on another. In the background, your friend's trying to decipher a scrawled note, and you effortlessly remark, "Oh, that's just a 9." Easy, right? Well, not for a computer. That's like teaching your cat to play chess. Cute in theory, but not really feasible without some serious tech acrobatics. Let's dive into the human visual system, our own onboard supercomputer. Each hemisphere of our brain is like a bustling gaming center, with 140 million neurons in the primary visual cortex, V1. It's as complex as a grandmaster's chess strategy and more synchronized than a swimming relay team. Yet identifying those digits in mere milliseconds feels as natural as a well executed butterfly stroke. This is where neural networks swing into action, offering a novel approach akin to training your AI chess partner. Picture them as digital octopuses, arms sprawling with nodes, which in their earliest days just flopped around, not knowing what to do with handwritten digits. This is where neural nets add another layer of intrigue. They don't just count octopus arms or tally chess pieces, they learn by example, by analyzing millions of digit patterns, much like how you'd train by repeatedly solving chess puzzles until complex strategies feel second nature. At the heart of this learning bonanza is a recipe for digital neurons, such as perceptrons and their twin sigmoid neurons, the rook and bishop of neural processing. A perceptron makes binary decisions, reminiscent of deciding if the pool is warm enough for a swim using just one toe. Sigmoid neurons, however, are suave. They blend inputs smoothly like a summer cocktail, adjusting ever so slightly and infinitely. Now, you might ask, how do we get from clumsy flippers to this lithe, synchronized learning? Enter backpropagation, the coach that reviews each fault in your stroke, sending signals backward to improve performance. Imagine tweaking your chess moves after each game, refining until you achieve the perfect checkmate. But instead of waiting for weeks of practice, the AI does this instantaneously, course-correcting errors as they appear. As we dive deeper, neural networks with multiple hidden layers, also known as deep neural networks, come into play. They are akin to mastering swimming in multi-channels, capable of transforming input data into the sophisticated pattern recognition needed to outperform traditional machine learning models like SVMs, just as a well-trained swimmer effortlessly outpaces a casual paddler. So, as you next marvel at a swift checkmate or glide effortlessly in the pool, spare a thought for the neural networks, the techno golems honing their skills in the shadows of our digital world, making sense of our scribbles and solving problems untold, while we sail through the seamless interface of technology. That's all for today's swim through the stream of artificial intelligence. Keep computing, keep training, and maybe toss a neural network or two into your next gaming strategy. Until next time, on Neural Dives, where the waters are deep and the digits are plenty.